Test the claim about the differences between two population variances, sigma squared sub 1 and sigma squared sub 2, at the given level of significance alpha using the given sample statistics. Assume the following. Remember that the null hypothesis H sub 0 is a statistical hypothesis that contains a statement of equality. If the claim does not contain a statement of equality, then its complement is the null hypothesis. So in this case, for our statement of equality, we're going to state that the two variances, sigma squared sub 1, will be equal to sigma squared sub 2. Therefore, the alternative hypothesis will be that the two population variances are not equal. Since this is a statement with a non-equal sign in it, this will be a two-tailed test. And so what we need to do is find the critical F value. The critical F value for alpha with n sub 1 minus 1 degrees of freedom for the numerator and n sub 2 minus 1 degrees of freedom for the denominator. Since this is a two-tailed test, use alpha divided by 2 to determine the alpha or level of significance in the F table. So since we started out with alpha being equal to 0.01, the value in the table will be equal to alpha divided by 2, which will be 0.01 divided by 2, and this will be equal to 0.005. So now we need to use the F table that has an alpha of 0.005. Then we need to go ahead and find the degrees of freedom for the numerator and the degrees of freedom for the denominator. And this will be taken from the information that's given. So n sub 1 is equal to 5, and n sub 2 is equal to 8. So therefore the degrees of freedom for the numerator will be 5 minus 1, which will be equal to 4. And the degrees of freedom for the denominator will be equal to 8 minus 1, which will be 7. So now let's find this value in the table. Alright, so this is the F table, and we're going to be looking for degrees of freedom for alpha equals 0.005. The degrees of freedom in the numerator will be 4, so it'll be this column here, and the degrees of freedom in the denominator will be 7, so it'll be this row here, and this right here is the test statistic of 10.05. Alright, so the critical value is going to be 10.05. And now we're going to go ahead and calculate the test statistic. Okay, so we know that F naught, F sub 0, our critical value is equal to 10.05. So if we're considering our diagram over here, and we've got this, remember this is a two-tailed test, okay, but we are not going to worry about what's down here at the left because our rejection region will be up here, so we can simply say that F sub C, our critical value, greater than 10.05 will be in the rejection region. So let's go ahead and calculate F sub C. Remember that F sub C is simply the sample standard deviation of the first sample divided by the sample standard deviation of the second sample. And we'll need to remember what those values are. And so that we note that the sample standard deviation for sample 1 is 7.4. So that goes in the numerator here. And we're going to divide by 5.9, which is the standard deviation for the second sample. And that means that f sub c is simply equal to this ratio, which is equal to approximately 1.25, which is what you're going to want to round to. So we round to 2 decimal places. And since that clearly does not fall in the rejection region, so we know that this does not fall in the rejection region. And if that's the case, we can simply state that we will fail to reject the null hypothesis. And we can further state that there is not enough evidence to reject the claim. This problem can be done using StatCrunch, but honestly it's easier not to use StatCrunch. But if you want to use StatCrunch, we'll go ahead and show that. So if you want to use StatCrunch, go ahead and open that, and then you're going to go and you're going to left click Stat, scroll down and highlight Variance Stats, come over, highlight to sample, and then you want to select with summary. So you're going to put the variance of the first sample, which is 7.4, into this field, your sample size, which in this case is 5, then your second variance is 5.9, and your sample size is 8, and then there are other things that you can do, but you want to make sure that this one is selected. You want to know that the ratio of the first variance to the second variance, and we're talking about the population, not the sample, is set at 1, and just simply left click compute, and now you have this particular setup, and it shows you that the ratio is of one variance to the next. We have a number, the numerator degrees of freedom is 4, the denominator degrees of freedom is 7, and we see that the sample ratio is 1.2542373, which matches the F stat of 1.2542373, and also you'll notice that that is the same as what we came up with using a simple ratio. And that's how you do this problem.